Okay, effective interest rates. So effective interest rates are about being able to compare fairly. So here's Luke, he's thinking about a loan of $35,000 and his bank has two rates. One that is higher, compounding less frequently, and one that is lower, compounding more frequently. So we have to figure out, well, which one is better and how can we compare the two of them. Okay, so an effective interest rate takes a nominal rate, which is this, 8.3% compounding monthly, and turns it into the same as what a regular annual is. So what it's going to do is it's going to take 8.3% PA and compounding monthly, so CPY 12, and it's going to make it equivalent to some other interest rate, PA, compounding annually. So this is the same as a different rate that compounds once a year. And we're going to do the same thing for 7.8%. So we'll get a 7.8% per annum compounding weekly, so 52 compounds, is equivalent to some other rate per year, which compounds once a year, and then we'll be able to compare these two nice and easily. Okay. So all we're doing is we're taking these rates and we're going to turn them into a different rate that does the same thing, just compounding once per year. Now, there is a fancy formula to do it, but because you'll always be with your calculator, we can go straight to the calculator. We're going to put 8.3% per annum in for 12 compounds per year. There is in menu, finance, interest conversion, effective interest rate. It's looking for, if you have a look in your library, nominal rate, so the 8.3, compounds per year. So we're going to put in 8.3 and 12, 8.3, 12, and it says that 8.3% per annum compounding monthly is the same as 8.623% compounding annually. So 8.623. Is equivalent to 8.3% per annum compounding monthly. And we do the same thing for 7.8. So 7.8, you don't even have to go through the whole menu. You can type EFF 7.8 compounding weekly gives us 8.1059, so 8.106. 8.106% per annum compounding annually is equivalent to 7.8% per annum compounding weekly. Now we've got a way to easily and quickly compare these two. Okay, so we're going to do option A first, calculating the amount of interest Luke would pay in the first year for each loan options. So we use this equivalent rate, the effective rate, because it's the same as compounding monthly. And to skip the hassle, we can just jump straight to this part. So $35,000 times 8.623 over 100. That should give us an interest amount. 35,000 times 8.623 divided by 100 gives us $3,018.05. 50 cents, rather, 5 cents. And we do the same with the second one. 35,000 times 8.106 over 100. Put that in. Times 8.106 divided by 100. This time we get 2837.10. Both in dollars. Correct the nearest cent. Last one, which loan should Luke choose and why? Luke should choose option B. Now he should choose option B because there is less interest owed. Now, if he was investing, he should choose option A. If he's borrowing, he should choose option B. When you invest, you want higher rates. When you borrow, you want lower rates.